This movie is for Unit 6, Learning Targets 6 and 7. Deals with properties of a rhombus, rectangle, and square. You will need your purple sheets out, as well as your math notes. We're going to skip this getting ready because you did do the investigation. The next slide, we know that a rhombus is a parallelogram with 4 congruent sides. We know that a rectangle is a parallelogram with 4 right angles. And a square is a parallelogram that has 4 congruent sides and 4 right angles. So you can see a square is a more specific type of rectangle and rhombus. Pause this movie, add this to your notes, press play when you're finished. Can you put the following terms into a Venn diagram? So you're going to put these terms here, and one here, using squares, rectangles, rhombuses. Add those to the Venn diagram, press play when you're finished. In adding these, you can see that squares are what's going to go in the middle because squares are more specific types of rhombuses and rectangles. Let's look at this stained glass window. Is parallelogram ABCD a rhombus, a rectangle, or a square? Explain. Looking at ABCD, see what you can identify. We have that angle B is a 90-degree angle. We know it's a parallelogram. So let's see what we can infer from that. Because it is a rectangle, since opposite angles of a parallelogram are congruent, that makes angle D a 90-degree as well. Now A and D, as well as C and B, are going to be same side interior angles. So those need to be supplementary, so therefore they're going to be 90 as well. This gives me all 4 90-degree angles. We don't know the length, so we can't say that it's a square. We're going to move on. We're going to add these 2 theorems to your purple sheets. The first one says, if a parallelogram is a rhombus, then its diagonals are perpendicular. So if we have all 4 sides congruent, then the diagonals, AC and DB, are going to be perpendicular, hit at a 90-degree angle. The second one says, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So if we know that we have a a rhombus, then we know that this diagonal AC is going to bisect angle A. So that makes angle 1 congruent to angle 2 because it's an angle bisector. Same thing here, 6 is congruent to 5, 7 and 8 are congruent, and 3 and 4 are congruent because in a rhombus, the diagonals end up being angle bisectors. Pause the movie, add these to your purple sheet, and press play when you're finished. A proof for this looks like this. You can just watch this real quick. I do want to keep some 2-column proofs in. If we're given that this is a rhombus, ABCD, we want to prove that the diagonals are perpendicular. Notice we can't use that in our proof. The first thing we can say is that A and C are equidistant from B and D, and B and D are equidistant from A and C. Now I know that because it's a rhombus, all the sides are congruent. So I know that B is the same distance away from A that D is. And I know C is the same distance from D as C is from B. And that's because all sides of a rhombus are congruent. Knowing that tells me that AC are on the perpendicular bisector of BD. Remember when we had 2 people in the room and everyone else had to stand equidistant from those 2 people? So we can see that AC would be on the perpendicular bisector of BD, since A is equidistant to B that C is. And that we call the converse, or the perpendicular bisector theorem. Now we know that AC is perpendicular to BD, since through 2 points there's one unique line perpendicular to a given line. And so that's just a real quick proof, not something you'll need to create yourself. But I know in the investigation we found that to be true, but this is a proof to prove that it's true. Let's find some angle measures. Using the properties that we've learned about a rhombus, I want you to find the angle measures, the numbered angles in this rhombus. Pause the movie, try this on your own, press play when you're finished. Right. We know that the measure of angle 1 is 90, since we know the diagonals are perpendicular. So the measure of angle 1 is 90. Then we know that the measure of angle 2 is 58. 2 and the 58-degree angle are alternate interior angles because we know AB is parallel to CD. Then we know that the measure of angle 3 has to also be 58 since the diagonal BD bisects angle D. So 3 and 2 are both congruent. Now, right here in this triangle, 1, 3, and 4 form a triangle, so I know they add up to be 180. And I can plug in my values for 1 and 3 and solve for what 4 is. 4 is going to be 32. And that's how you find all the angles. In this rhombus, I would like you to try to find all the numbered angles. See if you can also justify your answer why you're saying what you're saying. So pause the movie, try this on your own. I'm not going to go over the answer. This question is going to be one of the 2 questions that you'll need to answer at the end of this movie. Just make sure you write down your answer. Pause the movie now, press play when you're finished. We have another theorem to add. Let's add this to our purple sheets. If a parallelogram is a rectangle, then its diagonals are congruent. So that tells me if I have a rectangle, 4 90-degree angles, then AC is going to be the exact same length as BD. Pause the movie, add that to your purple sheet, press play when you're finished. In the rectangle RSBF, we know that SF is 2x plus 15, RB is 5x minus 12. Find the length of a diagonal. We know that the diagonals are congruent, so SF is equal to RB. Then I can replace those with the algebraic expression that I get. And then I'm going to solve this. So I'm going to subtract 2x on both sides, and then I'm going to add 12 to both sides, and then I need to divide by 3. So I get that x is 9, but that's not what the question is asking. It's saying what's the length of a diagonal? So I'm going to plug 9 back in to RB, which is 5x minus 12. 5 times 9 minus 12 is 33. So the correct answer here is D, 33. And it stems from the fact that in a rectangle, diagonals are congruent. If ln is 4x minus 17 and MO is 2x plus 13, what are the lengths of the diagonals of the rectangle LM and O? Then I want you to answer what type of triangle is triangle PMN and explain your answer. Go ahead and pause this movie, try this on your own, and then at the end of the movie, you'll need to answer this question. Okay, so now you are finished with the movie, and you can answer the questions that follow.